As John had said, when he got to go to South Carolina, everyone says, hi, y'all. Well, in New York, we like to be brief. So, hey, it's good to see you all, and it's a pleasure to be here. As Jack had mentioned, I'm a commissioner on the New York State Public Service Commission. Prior to that, I served 12 years in the legislature, in the assembly. And so I think I have a little bit of background with government. And Steve, what you were saying as far as when you go down to Washington, because I've been there quite a bit during my career, it's also important to go to the state legislators and to bring the people in personally, all your people, so the state legislators get to see them, and they can write a letter on behalf of all the people that they had in their offices too. So I think, you know, the more on board, the better it can be. It does make a difference when it comes to elected officials. So let me talk about when I first came to the commission. The chairman of the commission at that time said, I want you to meet someone. And what he really wanted was for me to take Jack away from him. So, but you know what? It was probably the best gift I ever got because Jack has really been wonderful. And he really has kept my spirits up. It's been a long time coming. I've been on the commission now almost 11 years. And trying to get a utility to partner with a geothermal project was extremely difficult. And basically at my wit's end, I spoke to Jack one day after getting rejected from gas companies and electric companies, but I'm not giving up on that gas yet. I still think that's important. I said to Jack, how about a water company? And I chose American Water and Bill Varley. He's a fellow Long Islander. That's where I come from. And we've had good success with a lot of projects in the state with American Water, taking over a lot of small water companies. That's something that keeps commissioners up at night, trying to manage the small water companies. And so I called Bill and I explained to him I wanted him to come to my office and meet Jack and let's just talk. And from that day was September 11th in 2013. Bill brought, who now is the president of Long Island American Water, Brian, with him. And the four of us sat together, and I just kind of pulled my chair back and let the magic happen. There was excitement on both their parts. And when you're doing a project and, you know, people say, well, you know, it's all about thinking out of the box, and that's why you have to be persistent in life, because we know what can be done. Let's try something new. You can always go back to what was done before. Let's do something different. And out of that came this project that we have in a Long Island school that was built in the 1950s. And I don't know, most of you come from all over the country. In the Northeast, most of our schools are old, and they do not have air conditioning. And when the project was over, the superintendent, he's amazed by this whole project. And he knows about geothermal. He has it in his home. And he said, I never thought something like this could be done. And Bill will talk about the technical part and the payback period. But really, Jack brought to the table a really important partner, and that's Bosch. And so they came on board and helped design the heat exchange and work with American Water to put this pilot project really on track. And everyone that comes to see this project is completely amazed. There's so many positive offshoots. Right now, I don't see any downside to this project. It has a small footprint, and in New York, you know, if you've ever been to New York City, there's not a lot of room to do things. And so this project to work in New York City in their schools is really important. And of course, we all know the children are our future. And it is difficult to learn. And I cut out of one of our local newspapers, if I might read this to you. This gentleman went with his wife to his son's 5th grade open school night. And I'm sure all of you, as proud parents, love to go to your kids' open school night, meet the teachers and everything else. And he said, as he climbed the stairs to the 2nd floor, where his son's classroom was, it became hotter and more uncomfortable. So he said he noticed the heat rising with every step that he took. And it was about 7:30 when they were in the classroom, and it was uncomfortably warm. The next 30 minutes was an exercise in trying to focus on the teacher's presentation while thoroughly distracted by the heat and the humidity in the classroom. To say that there were miserable conditions in which to spend 6 hours a day is really an understatement. So he left the experience of meeting the teacher thrilled, but not so happy with the conditions in the classroom. And he said, if we cannot afford air conditioning in our schools when we pay such huge tax bills, and let me tell you, in New York and Long Island, we pay huge tax bills, and people feel they don't really get enough of their bang on what they're paying for. We really must face the reality that for many days each school year, our students and teachers endure horrific heat that would be unacceptable at any regular workplace. And I think that's really the beauty of what this project has done. You now have teachers trying to bump other teachers to be in the school. You have janitors trying to bump other janitors. The school actually this summer rented out some of their classrooms to a college, so they made some money on the deal also. It's just amazing. And as the last time I brought people on a tour of the project, the superintendent spoke about the added extra of having security now in their building because they could keep the windows closed. And every classroom has its own temperature control, even though it is controlled remotely at this point right now. But what it's done is made such a difference. And as was mentioned here before, your industry, I think, it's all about timing. Because when people hear about this project and want to come on a tour, they say, what's the catch? It's like, there is no catch. It's really simple technology. And we should be ashamed in this country that we haven't really embraced our own technology. People in other countries have, but we haven't really. So I think this is the time now for your industry to really blossom. And so congratulations to the new board members. You have a lot of work on your plate, but again, timing, it's all about timing in life, and this is the perfect time. So I'd like to bring my partner, and as I've said before, bringing Jack and Bill together was almost like creating a blind date. You weren't quite sure how it was going to turn out, but you know what? They're dancing together great, and with the help of Bosch, this has been a wonderful partnership. So Bill, if you would.
Sure. Yeah, absolutely. Good morning. Before we get into this, I just wanted you to know about American Water. American Water is the largest investor-owned utility of water and wastewater in North America, actually. We operate in over 16 states that are regulated by commissioners such as Commissioner Akampora. We serve a population of over 15 million people every day with water and wastewater services. We employ probably a little over 7,000 people. So it's a very large business. We have a large footprint. That's why this project's really exciting, and this is one of the easier presentations I can do because I really don't have to prepare for it because we lived it together. And Don Penn, incidentally, was the design engineer on this along with Bosch. So I'll go to the first page. And quite frankly, when I first got the call, I didn't quite understand why I was being brought in. I knew geothermal. I'm an engineer by trade. And coincidentally, I did work for Lane Christensen for 13 years as well drilling and water supply construction. So I knew of boreholes, but I wasn't quite sure what we were going to achieve here. The one thing that we've done is take a look at our water supply. The water supply in Long Island is all wells that are about 500 feet deep. And our water temperature is 55 degrees all the time. steady state. Maybe a little bit warmer in the summer because we have low, shallow depth of bury for our pipe, but traditionally it's 55 degrees. This system that we operate in New York on a average day pumps about 35 million gallons a day, and on a peak day, because people love green lawns on Long Island, it's about 80 million gallons a day. So when we took a look at this, and he was explaining, why can't we just take the Earth's temperature and bring it to the surface? Why do we have to drill 150 boreholes that are 200 feet deep and take up a huge footprint? And probably for a project like this, which was a 40,000 square foot school, it would cost about $1.5 million, maybe $2 million to drill these wells. And don't forget, we're operating in the Northeast where we have significant labor costs, a little different, in different parts of the nation. But this would have been about $1 million, $1.5 million. So he said, how can we eliminate this and use our source of supply and deliver the Earth's temperature to the building instead of going down to the Earth to retrieve it? Use the same technology, but bring the 55-degree temperature to the building. So what we came up with was a pilot. So this was a 40,000 square foot school built in the 1950s. And this is a schematic of the pilot. You can see here that we have console units within a classroom, and your traditional closed loop now you see in the green line there. The difference about this, and we call it the special sauce, which was, Don came up with this when he did the design, which is kind of unique. Instead of going back to the Earth, now you see the water main there, and we're delivering a 4-inch water line to this small little building on the side. We put in and installed a heat exchanger, a food-grade heat exchanger that's used in the food industry. So essentially, instead of going down, this replaces the boreholes. Now you have 55-degree water going through the heat exchanger. You have the closed loop going through the heat exchanger, and it's acting just as the Earth would. You can see as part of this pilot a 500-foot diffusion well that after the water goes through the heat exchanger for the pilot portion is being put back into the aquifer we took it from. We wanted to make the project as green as possible, but there's one other, and I wouldn't say catch, but there's one real main driver behind this pilot. First and foremost, American Water is a water supply company. We supply drinking water and potable water to our customers. And at no time did we want to ever compromise the integrity of our source of supply. And that's the driver behind the length of this project. Right now, we're testing water quality on the way in and on the way out. And we're doing the standards that were required by the EPA and the federal government. And we're actually going over and above that with belt and suspenders. Because let's face it, you'll see at the end here, the health department is going to be concerned with water quality. And the biggest, I would say, not risk, but I'd say the biggest change you're going to be looking at is water temperature. So, and this is nice being able to do this presentation. People actually understand geothermal. And I explain the water going in and going out. Right now, during the wintertime, when we started this project about February, we're seeing about a 2 to 3 degree temperature drop in the water, which is no great shake, and that'll depend on the temperature outside. And the beauty of this pilot, right now this school is operating on about 150 gallons a minute going through that line. But if it gets really cold, we can open the valve and throttle it and put 250 to 300 gallons a minute, get more BTUs created so we can also heat the school. Now in the summertime, we've seen about the water temperature actually in our water main goes up from 55 to about 58, 59, 60. So we're seeing a temperature increase in the really hot days in the summer, anywhere between 3 to 5 degree temperature increase. No, nothing really significant. Because at the end, we'll talk about how we can take this forward. So the basic thing that I talked about was the heat exchanger. This is the heat exchanger. That $10,000 stainless steel 1-foot section, and I call it a radiator for lack of term, replaces $1.5 million in boreholes. When you think about it, it's so basic, but it takes basic technology, but it's pretty unique. So you can see the green line. We label them conveniently, water supply line, and the green line would be the interior closed loop. The closed loop, we had about 10% glycol solution because we didn't want to freeze in the trenches. We probably could have gotten it with just plain water. So now you've got this 55-degree water going through heat exchanger, the loop coming through and just exchanging the heat right at the interface. I'm sorry. You can see there, that's the recirculation pump for the glycol line within the building. It's skid mounted right off the shelf with controls. Nothing magic about it. This is a picture within a classroom. This project probably a little bit different than used to. We had a lot of console units in this project. We did have some overhead units, but you can see the two brand new console units sitting next to the old clunker heating unit. And don't forget, this project, this school never had any cooling in the summer. Never had any. And right now with the test data that we have and what we're showing is we are actually providing cooling and heating with using zero fossil fuel and still a $40,000 reduction in operating costs. Think about it. $40,000 reduction in total cost while you're providing air conditioning, zero fossil fuel, no gas, nothing. Just a little slight increase in electrical costs because of the compressors, but nothing earth-shaking. So let's go back now. This is our pilot right here. And incidentally, I think with thermal loading, I work with Don. He's schooled me very well in this thermal loading. This school, prior to our installation, had a thermal load of about 72 kBTU per square foot. We've dropped it to about 50. So if you look at that in terms of carbon footprint reduction, that's about a 30% carbon footprint reduction. And with all the new EPA laws that are going to be coming down, we think as a water supplier, we can participate in that and help some of these coal-fired plants reduce their carbon footprint indirectly. And also, too, think about it. Over 4% of the electricity in the United States is used to move and transport water. So if we can efficiently and effectively use our source of supply, and that brings us to the punchline. When we're done and we're satisfied with all the water quality data that we have, and which, by the way, we've seen no degradation in water quality. We monitor consistently right now at our main plant pH, chlorine residual, temperature, turbidity. So we're taking a look at this instantaneously every 2 minutes. And we've also done a sampling regimen where we test every 2 weeks for every constituent under the sun, every organic compound, any inorganic compounds, everything we're required as a water supplier. And we've gone as far as even streaking plates to see bacteria colonies just to get people comfortable with the idea. Because when you see the last picture here, this is why we're doing it. So here's the punchline. When we're done with this testing, this will be a totally renewable source of energy. We'll take the water from our supply, put it through the heat exchanger, ensure the water quality, and it just gets redirected and goes right back to our system. It never leaves our system. It's just going through a 1-foot piece of stainless steel corrugated pipe, I call it. So we're making sure that we get all our health departments comfortable with it, ourselves as a water supply comfortable with it, and this could be something that we could do in the future. Now, how many could you do? It's an 80 million gallon a day system. So if we're putting 150 to 200 gallons a minute through a system like this, we'd have probably designed a mass balance for this portion of our system to have, okay, you're allowed this many BTUs before you start accelerating or increasing water temperature in the system. That's the biggest concern, increase in water. But in Long Island and a lot of other places where irrigation is prominent, this water does not stick around long. It's usually in and out the door. So we're going to be working over the next year to go through another cycle of heating and cooling, testing, getting data in terms of cost savings so we can deliver this project and start spreading the word. I mean, this is great for your industry. It's great for our industry. And Commissioner Akampour was talking about property taxes. Property taxes on Long Island are insane. I mean, for a 2-bedroom house I pay about $15,000 a year in property taxes, which is insane. But 65% of that goes to schools. So if we can drive down the operating costs of the schools, we can in turn drive down property taxes. We can drive down costs of our water to our customers because we're a pass-through in property taxes. Or, better yet, let's take that savings and drive it back into the schools, have better programs, and expand our program. So I think, Jack, did we want to open up for questions or anything? Commissioner Akampour?
Add something else. I know a lot of you are familiar with cooling towers, but in New York, we've recently had a really bad outbreak of Legionnaire's disease. About a month ago, 12 people died. Just recently, within the past 2 weeks, 2 people have died. It was my suggestion to the chair when she was speaking to the commissioner of the health department, maybe instead of having cooling towers, you should have a system like this, rather than worrying about cleaning them, which the city now passed a law telling people you have to clean your cooling towers. I mean, I think they're kind of antiquated. So this brings another aspect. Bill, wouldn't you agree? There's so much opportunity for more application of this type of a system. And that's why, again, I mentioned about timing. Sometimes your timing just isn't there. I think the opportunity now is coming, and with greater understanding, your lobbying of elected officials, because I can tell you, when I served in the New York State Assembly, if there were, out of 160 assembly members, 5 people who understood anything about energy, utilities, phones, cable, it wasn't happening. So it's really important to have that dialogue. So I think your time is now. You're really on the crest of really becoming an important player in every state and throughout the country.
Commissioner brings up a really good point. What other applications we could do with this? Think about it. There's gray water systems out there now that treat water, and you have gray water going through the system and used for irrigation. We can plug and play this right now. Put a heat exchanger in, put the water into gray water. You don't have to worry about water quality. Think about California, where you have a significant drought and you have probably 40% evaporation in air conditioning units. You could use this as a closed loop system. The commissioner spoke about Legionella. Highly unlikely, but we've actually gone belt and suspenders on testing for that, just so we have it. Because there's going to be some pushback, and there's also going to be pushback internally to make sure our supply and our integrity is there. But I think that there's huge opportunities. And if you look at, and the first question we get is, what is payback on this? So this school was kind of hard to get a payback because you really didn't have the cooling. But if you took a look at a 40,000 square foot school and a new installation, you provide heating and cooling, probably be around $2 million. With our type system, if you install it, the installation cost would probably be $2 million, and we've cut off $1.5 million in that front-end cost by eliminating the boreholes. So a traditional system would probably cost operating costs about $165,000 a year in operating costs and probably $25,000 a year in maintenance, and would only last probably 16 years. Now, geothermal, as data shows, it lasts in excess of 24 years. But the operating costs on a geothermal system of this size with our technique would probably be about $65,000 a year. Then you replace some filters at maybe $8,000 to $10,000. So if you look at that replacement time versus the upfront cost and the operating cost, this system, when you compare apples to apples, would have a payback period in less than 7.5 years. And then in perpetuity, because now you're just recirculating water. So there's a lot of good that comes out of this, and I think you're going to be the ambassadors for this, and we're going to be working closely with the industry. So thank you very much.
Thank you.